Okay, everybody, this is chapter 10, section 3. This is also dealing with radicals. So remember, radicals are a square root symbol, and today we're going to work with trying to put radicals together that are alike. So you want to think of like being able to add like 4x plus 6x gives me 10x, or 3x minus 5x gives me a negative 2x. So it's kind of like putting variables together. Okay, so keep that in mind as we're going through this. There's a couple definitions up here at the top. Like radicals have the exact same stuff under the square root. Now, same stuff means values. So I don't know the scientific term for same stuff, but it's going to be values, and they could be numbers and variables. Okay, so they would have like the square root of 7 and the square root of 7 underneath the radical, and I'm adding or subtracting them. Okay, also I can multiply them. We'll talk about those too. Unlike radicals, don't have the same exact stuff under the radical, so the values won't be different, the variables might not be different, stuff like that. Okay, so a little bit of review here. If I've got this equation 3x plus 5x minus 2y, I can put like terms together. We've done that since August. So 3x and 5x is 8x, but I can't put it together with the 2y, so I'm just going to leave it like that. Simplified as far as I can go. All right. So the same rule applies when we're dealing with radicals. I've got the coefficients 3 and 5. The radical square root of 7s are the same, but then I've got this different one over here, so can't touch that third one. But I can put the first two together. It's 8 square root of 7. Don't change the value inside the radical. And then we're going to just be able to say minus 2 square root of 5, because square root of 7 and square root of 5 are different. Okay? So I'll let you guys kind of do these two. We'll do these together, and then I'll let you do the bottom two on your own. The radical is the same. That's the first thing I want to look at. Are they the same? Yes, they are. I can add then the coefficients, so I get 15 square root of 11, and that's where I want to leave it. We're not going to stick the square root of 11 in our calculators and multiply it to 15. We'll just leave it like that. So same thing here, but this one you got to remember, it's kind of like what we do with x's and stuff. There is a 1 right there. So I'm really subtracting the coefficients because the radicals are the same. So I'll get a negative answer, and it'll be negative 4 square root of 3. Okay, so why don't you pause it and try these two on your own that are down here at the bottom, see what you get. So obviously I'm going to get, I can put these together because the radicals are the same. I'm going to get a negative answer because the 8's bigger than the 7, so negative 1 square root 2. Over here, the radicals are the same. They're both radical 5, square root 5. And I could put the coefficients together, 7 square root 5. Okay, so those should be pretty easy for you. They're all the same, so I didn't have to think too much there. Just being careful with our signs and stuff like that. So we'll go here, and now we got different ones, and I want to be able to put them together. Now we've got to go back and think from our last section. Can I simplify this radical? They're not the same, so I can't put them together. But can I simplify the square root of 12? And I can't. Remember, I look for a perfect square that's a factor of 12, and 4 is. 4 goes into 12 3 times. Hey, look at that. Now I'm getting the same radical. I might be able to put this together after all. Okay, so we're going to give you stuff that you can simplify that gets you a radical. So, you know, think, I want to be able to put them together. 3 I couldn't do anything with, but I bet it's going to be coming out of the other radical. So don't take some of that guesswork out and use this to help me. So 5 square root of 3, square root of 4 is 2 square root of 3, and now I can't put them together because the radicals are both the same, so I get 3 square root of 3. Okay. Let me do this one with you, and I'll let you do one by yourself. 7 I know I can't do any with, so I'm going to bet that 7 goes into 28, and it does. It goes in 4 times, so I can take 2, square root of 4, square root of 7. I'm doing this in baby steps here, so if you kind of get this, just bear with me. I'm going to get 4 square root of 7, but I'm going to get a 2 out of that, so 2 times this 2 is going to give me 4 square root of 7. Now I got the same radicals together, so I can put those together, and I get that. Okay? Let me clean this up for a second. All right. So once you pause it and try this other one on your own. This one's a little bit tougher because I can do something with the 32 and the 18 first. So pause it and give that one a shot. Okay, so once again, 32 and 18 are not perfect, but they do have factors that are perfect, and I picked the biggest one, so hopefully you're kind of thinking along those lines. 16 goes into 32 twice. 9's perfect, goes into 18 twice. So the square root of 16 is 4, and 4 times that 5 gives me 20. Square root of 2. Square root of 9 is 3. So 3 times that 4 gives me 12, square root of 2, and then look at that, I have radicals that are the same. So now I can put these together, and I'm going to get 8 square root 2. Okay, so those are test questions right there. You need to be able to do that, especially this last one. This one would be one that you really got to be able to do and think it through. But we're going to give you ones that can be put together, so think ahead a little bit and kind of plan, looking for perfect squares, the biggest factor that can come out of both, stuff like that. Okay. All right, we're going here. We've got a little distribution multiplication, little rule here too, that I can multiply these two numbers in the radical just like regular old numbers. Okay. So I'm going to kind of do that. There's a couple different ways you can do this. I'm just going to do it this way. It might take us a little bit longer, but I want to get you the kind of the underlying principle of this, and then get better at this. There's shortcuts you can take. So we'll go a long way first. That's going to get me the square root of 60. And then when I multiply it to the 3, I'm distributing here. I can't put those together because the 3 is not under the radical, so I'm going to go just 3 square root of 10. It's just like, when I multiply 3 to x, I get 3x. Well, this is doing the same thing. I'm kind of looking here. I think that I can reduce or simplify 60, looking for a perfect square that goes into it. 4 goes into it 15 times. So I need to do that. I can't simplify 10 because I can only break it down to 2 and 5. Neither one of those are perfect. So here I'm going to get 2 square root of 15 plus 3 square root of 10. And that's as far as I can go because the radicals are different. Okay. This one's going to get a little intense here. This is foiling. Okay, so hopefully remember, first terms is F, outside O, outside terms, I is the inner terms, and L is the last terms from each parenthesis. So 6 times square root of 6 times square root of 6. I'll do this a long way, but let me just say something. I'll get 36, but from the last section, if we multiply the same radicals together, I get just what's inside that radical. So I should really just get a 6. But I'm going to do this a long way first, okay? That was F. Then O is the outside one, so I'm going to multiply those together. I get square root of 18. I, innermost, so I'm going to get negative 2 square root 18. Remember, multiply the radicals together. And then L, last, I get negative 2 square root of 9. Okay, so I got a lot of stuff here to think about. I do have some perfect squares that I could play with, and I do have some things I could put together. So this will take us a little bit. Square root of 36 is going to give me 6. I can put like terms together. I'm going to do that first, or something else I could do with this later. So remember, there's a 1 right there. So negative square root 18, or negative 1 square root of 18. And then I get a negative, but 9's perfect, so it's 3. And 3 times 2 gives me 6. Okay? So I put some stuff together, and I still got a little bit more to do. I can put these together. Okay? That gives me 0. Negative 18, I can break it down into a 9 times 2. 9 is perfect, so I get 3. So my answer is really negative 3 square root of 2. A lot there. You got to be thinking. Okay, make it small. You got to get back to that list of perfect squares that we talked about a while ago. Remember what they are. Okay. All right. Once you pause it, give these a chance here. Work at it. Make sure you're reducing as much as you can and only putting things together that are alike. So hit pause and get going. Okay, so I put these out here, and I'll just explain real quick. I think the first one's pretty easy, just distributing that. I do get the square root of 12 by putting these two together, so I could simplify that down, and I get 2 square root of 3 plus 5 square root of 2. Can't put those together any more than that, okay? You got this FOIL over here. It gets really complicated here, so hopefully you gave it a good shot. Once I FOILed everything out, I could put these two together because they had the same radical. It gives me negative 2 square root of 18. When I distributed these out, I get the square root of 36, and so that gives me 6. So 6 times 3 gives me that 18. And then the square root of 9 was 3. So 3 times this negative 8 is a negative 24. Okay. So I put those together, and that gave me this negative 6. And then I was able to simplify the 18 back here. 9 times 2 gives me 18. 9's perfect, so that's the square root of 3. And square root of 3 times negative 2 is a negative 6. And then that's as far as I can go. So, you know, just a lot of stuff to look at there and be able to remember and do. You just got to, you know, be careful and take your time. There's nothing to rush through. Okay? Okay. These are really not appropriate for what we're doing in our class. I'm going to put them up. Just take a look at it. There's a lot of stuff that we haven't taught you this. This is more, you'll get it in advanced algebra 2 or something like that, or even some pre-calculus. So I'm just going to put it up. I'm not going to really teach it. There's a couple things that you would use in geometry, but it's not the actual math. So I'll just put it up and look at it. I'll talk about it really quick, and then we'll go to the section summary, okay? Okay, so here's these two problems. So this is really kind of out there. We have this thing called a golden rectangle. It's a thing that kind of exists in nature, that things are proportional to each other, and that's something you learn a lot about in geometry next year. So what they've given us, this golden rectangle rule up here, applies to a lot of things. Like you guys see shells and rings and trees, and in this case they're looking at these ferns, and there's this ratio that just kind of exists in nature that we can use for a lot of different things. So it's 1 plus the square root of 5 over 2. So I converted that ratio that kind of exists into a fraction, and I set it equal to, you know, this other fern that they're giving us. They want us to find the width of that head of the fern. So I have length on top, width on the bottom. They give that to me over here. I can do cross product, so I multiply diagonally across the equal sign, and then I get this. Okay, and then I'm solving it for W, so I had to divide by this 1 plus the square root of 5 both sides. So I come up over here, and I get this. Okay, I can't have a radical in the denominator. We learned that last chapter or last section. So I had to get rid of it. Now what I have to do is something called multiplying it by the conjugate, which means I change these two signs. I do the opposites, and I had to multiply it top and bottom. We did that last section. So that's something that, you know, wasn't really being taught to you. We just had to tell you this. So when I multiply it up, it gets rid of the I did a little FOIL right there. It gets rid of the radical in the bottom, gives me a -4. I can reduce that whole fraction by that, and I get this, and then I multiply it out, and because of rounding and stuff, the answer comes out to the width is about 2.5. Okay, so a lot of math right there, stuff that a lot of you are smart enough, but you'll see it later on in other math classes. So the second question is kind of the same thing. That golden rule, once again, I used it again. That exists in nature. And I have a rectangle. It's got a length of 12. So I have length over the width. And I kind of just did the same thing. It's the same steps, just I have a different number. I had a 4 in the other problem up here on top, and now I got this 24. I'm doing the same old math that I did before because it's the same ratio. And when I do all my math, I get down to about 7.4 is the width of the rectangle when it has a length of 12. Okay, all rectangles are proportional to each other, just kind of like circles are. So that's, you know, some old guy some long time ago kind of sat around doing a bunch of math and figured that one out. Okay, so in your section summary, we want to put like radicals together. We can multiply radicals like numbers. And we always want to be able to simplify a radical as much as possible. So that's taking out, you know, a perfect square as a factor and being able to simplify it and do whatever we can with it, okay? So that was kind of a tough one. So make sure you're doing your practice and your assignment and get that done. And once again, if you need any help, email me and I'll be glad to try to walk you through it, okay? But know your perfect squares and know what the square roots of them are. That helps a ton.